All right, folks, we have learned so far how to identify 12 of the 16 main points on a circle on the coordinate plane. And so now what we're going to do is we're going to now move on to the last 4 points, which I call the points that are at a 60-degree reference angle to the center. Let me show you what I mean by that. This point, this point, this point, and this point. They create kind of a tall rectangle with each other. If you were to draw a line from each one of these points to the other like that, it would create a tall rectangle. And you'll see here that if I put a 30, 60, 90 triangle in here, you can see that this leg runs along the x-axis. This line is perfectly vertical, creating a 90-degree angle. And that the angle here between the center of the circle and that point is a 60-degree angle. You'll also see over here at this point, also a 60-degree angle up to this point from the center. Now, it's a 60-degree reference angle. It's the 60 degrees from the x-axis here on the left side. Similarly, this point down here is also at a 60-degree reference angle, right? 60 degrees right here. And this point down here is also at a 60-degree reference angle. Okay? And so we know that we're basically going to use a 30, 60, 90 right triangle to try and identify these coordinates. Now, again, let me remind you that when the hypotenuse, if the hypotenuse is the radius, we'll put r. If the hypotenuse has a length of r, then the short leg has a length of r over 2. And that the long leg has a length that's equal to the short leg, r over 2, but it's multiplied by the square root of 3. So we have to multiply the square root of 3 times r over 2, and that's going to be the length of the long leg if the hypotenuse is r. So if we go over here, if we look at this point right here, if we put this 30, 60, 90 right triangle in here, we've got a 60-degree reference angle. We know the distance from here to here is, in this case, is 5. So that means that the short leg is 5 over 2. And that means that the long leg is 5 times the square root of 3 over 2. And therefore, if the center of the circle is at the point 7, 9, we know that the x-coordinate is going to increase, because we're going to the right, it's going to increase by 5 over 2. So all I have to write in here is 7 plus 5 over 2, comma. The y-coordinate is 9, but then it's going up. So that's 9 plus, and it's going up by 5 square root of 3 over 2. So we're just going to put 9 plus 5 square root of 3 over 2. And that's the coordinate of this first point up here. Now let's identify this one over here. Let's put this one in here. Okay. We know that the radius of the circle is 5, so we'll put that on the hypotenuse. The distance from the center to one of the points is 5. The short leg on this 30, 60, 90 right triangle is 5 over 2, and the long leg then is going to be 5 square root of 3 over 2. And so, if the center is at 7, 9, the x-coordinate is going to the left. This x-coordinate is to the left of this one, so we've got to subtract. It's got to go down by 5 over 2. So that's 7 minus this distance, which is 5 over 2. So the x-coordinate will be 7 minus 5 over 2. The y-coordinate is going up. It's higher than 9. So we have to add. We have to add this distance, which is 5 square root of 3 over 2. So 9 plus 5 square root of 3 over 2. And those are the coordinates of that point right there. Now let's try this point down here. We'll use this one over here. Let's erase this. Put in a 60-degree reference angle from the center. The radius from the center to the point on the circle, the radius is 5, because we're told that the radius is 5. And if this distance is 5, the hypotenuse on the 30, 60, 90, the short leg must be 5 over 2, and the long leg must be 5 square root of 3 over 2. And if the center is 7, 9, 7 comma 9, the x-coordinate is going down. So we're going to subtract. We're going to subtract the distance from here to here, which is 5 over 2. So the x-coordinate will be 7 minus 5 over 2, comma. The y-coordinate is now going down. It's decreasing. So 9 is up here. We have to have a smaller number down here, so we have to subtract this distance. So we have to subtract 5 square root of 3 over 2. So 9 minus 5 square root of 3 over 2. And those are the coordinates of that point. Last one. The really last one. The last of 16 main points. We're going to use this one. And as you can see, we have a 60-degree reference angle between this point and this point. This is a 30, 60, 90 right triangle. The distance from here to here, the radius is 5, which is also the hypotenuse of this 30, 60, 90 right triangle. And if the hypotenuse is 5, then the short leg is 5 over 2. And the long leg is going to be 5 square root of 3 over 2. And so now the x-coordinate, if the center started at 7 and 9, the x-coordinate is 7, and we're increasing, we're going to the right. So we want to add this distance, and this distance is 5 over 2. So that's 7 plus 5 over 2, comma. The y-coordinate is 9, and we're going down, so we're subtracting this distance, which is 5 square root of 3 over 2. So we're going to go 9 minus 5 square root of 3 over 2. These are the coordinates of that point. Okay? That's it. That's all 16 main points on any circle on the coordinate plane. Oh, let me show you, because I did this with the other ones. Let me go ahead and do this. Do an example. If you told me there was a circle that had a center at, let's say, 7 and negative 4, and it had a radius of 3, then these four 60-degree angle points, the first one would be at 7 plus 5 over 2, comma, negative 4 plus, oh, sorry, I put 5 over 2. Sorry, the radius is 3. It would be 3 over 2. 7 plus 3 over 2, radius over 2, and then negative 4 plus 3 square root of 3 over 2. Notice how on the 60-degree angle points, basically all we did was we took this number and put it over here, and we took this number and put it over here. That's all we did. So for a 60-degree angle, the 3 over 2 goes over here, or the radius over 2 goes on the left, and the square root of 3 over 2 goes on the right. But for a 30-degree, it's flipped around. For that point over there, it would be 7 minus 3 over 2 and negative 4 plus 3 square root of 3 over 2. For this point down here, it would be 7 minus 3 over 2 and negative 4 minus 3 square root of 3 over 2. And then for this point down here, it'd be 7 plus 3 over 2 and negative 4 minus 3 square root of 3 over 2. And that's the 16 points, 16 main points on any circle. You can do this with any circle on the coordinate plane. All you have to be told is the coordinates of the center and the radius of the circle, and you can identify all these points. What I'm going to do in the next video, I'm going to do one more wrap-up video where we take one circle, I identify a center and a radius, and we do all 16 in like a minute or two, maybe 3 minutes, okay? All right, I'll see you in that video.